solving systems of equations. This is a great skill to have going into calculus, especially AP calculus, where you're going to be asked to find the area enclosed by curves or area between curves, area captured by curves, and you're going to end up with things that look like this. You're going to end up with, I don't know, maybe having this. And let this be the sine curve, if you don't mind. Pretend that that's a really good sine curve. It's lousy, but pretend if you don't mind. And then say, well, this is the cosine curve. And in calculus, what the question will come back and it will say, you'll be asked to find, well, what's the area enclosed? Well, you'll be given an interval in the case of this because it's a repetitive function, but you'll be asked to find this area here. Well, the only way you could possibly find this area here, the only way you could use this great calculus that you're going to learn is to be able to tell the person, tell yourself, what are these points of intersection here and here? So here we are practicing that skill right now. You practiced it in algebra. I'm sure that you did. But this is a little bit different because our systems may be nonlinear. As a matter of fact, they may be non-functional. They could be circles. In this example that we're going to do today, though, they are not. So let's look at at this one right here first. I think this one works terrific. And it is solve the system. Y equals x squared minus 4. So we're being asked to solve the system. Solve the system. That is to say, find where they intersect. Solve the system. Find where the equations intersect. And the second equation might be 2x minus 1. Now, this one is already really set up to do what we wanted to do, but just as a note to yourself, this is what I usually do. I call one of them E1 and one of them E2. If I revise them, then I'll call them, if I revise this one, I change it, I move it around, I'll call that new one RE1, revised equation 1. It's a method of keeping track of where your equations are. But in this case, they're already set, and right, we want where they meet, and where they meet is where their heights are the same. Isn't that right? Where their heights, where their y and x values are the same, so we want this. So what are we going to do? We're going to set these equations equal to each other. 2x minus 1 is equal to x squared minus 4. And then start solving. I think what I'm going to do, frankly, oh, by the way, this function is not that. This is a separate function. This function probably looks like, well, the function that we're looking at today looks like this, I think, right? The blue one looks like kind of like that, and the green one looks, I don't know, something like that maybe-ish. So we're looking for this place here and this place here, I think. Okay. So what I'm going to do is just, I have them set equal to each other. I'm just going to start moving everything over. This is positive 2x, so I'm going to add negative 2x to both sides, and this is negative 1, so I'm going to add positive 1 here, and if you add these together, you'll get 0. 0 equals, right, here's x squared minus 4, right, minus 2x plus 1. Take a quick look. Anything we can combine here? We can. Here's the x squared. Here's the negative 2x's, right? If I take negative 4 and positive, I get negative 3. Set that equal to 0. Now, this is just a quadratic, and I think this can be factored actually quite nicely, can it? So here, I have this in a new form. Right, this is the combination of those two functions. So from here, I want to factor this, and then solve it. So factor. So we're looking for numbers that when we multiply them, we get negative 3. When we add the same two numbers, we get negative 2. So I'm going to take x here and x here, and I'm going to take negative 3 and positive 1. Are you buying that? Anybody? Anybody buying that? All right, and set that equal to 0. So I was talking to a student today, and I said, well, now we're going to use the zero product property. He said, well, what would have made me think to use that? I'm not making fun of this guy. He's pretty sharp. But what I would certainly argue is, isn't that we want a number times another number is equal to 0. And the zero product property says if we have any number of factors and we multiply them together and the product of those factors is 0, at least one of the factors must have been 0. So that's what I'm going to do. So I'm asking myself the question, when is x minus 3 equal to 0? It's when x is equal to 3. And when is x plus 1 equal to 0? And the answer to that question is x equals negative 1. Now, we're not truly solving this quadratic. We're solving where these functions meet each other. We're solving for this place and this place. So we cannot assume these y values. So we have the point 3 something, and we have the point negative 1 something. Why is that true? Well, we solved and got x is 3. It's x, y. This is the x value. It's x, y here. This is the x value. Then what? Go back and plug the value into one of the equations. And when you plug the value back into the equation, I believe that we get the point 3.5, right? 3.5. 2 times 3 is 6, minus 1 is 5. And negative 1 here, we get 2 times negative 1 is negative 2, minus 1 is negative 3. So we get the point there. And this is the point here, and this is definitely not the scale, so please forgive me. I don't want any comments, about how dumb I am. I get it. This is the point negative 1, negative 3, and this is the point here, 3, 5. And I know by scale it doesn't look like that's true, but this is not a scale drawing. This is just something that I want to see inside my head. So, example 1. All right? I hope it's helpful, and I hope you're practicing this. When you get to calculus, your professor will love you when he or she asks you to find the area enclosed, and you surprise them by starting by looking for the intersection of those two functions. So good for you.